responsibly to
Recording in
build
progress.
cities and the future in a smarter way. And it all starts with BIM. BIM is the holistic process of creating and managing information for a built asset. Based on an intelligent model and enabled by a cloud platform, BIM integrates structured, multidisciplinary data from planning and design to building and operations. From architects, engineers, and contractors to owners and operators, everyone can collaborate remotely to create and manage projects in a better way. BIM also generates insights that empower decision-making and accelerate better project outcomes. Design teams can use computation to quickly generate and analyze multiple options, focused on results. Manufacturing processes help teams to design, optimize, and prefabricate components in factories that are then transported and installed on site using accelerated assembly methods. With design, construction, and operational data, BIM produces a dynamic, up-to-date digital representation of a physical asset. This digital twin enables informed decisions across the entire project lifecycle and sets the stage for future projects. This is BIM. It's the foundation of a digital transformation in the architecture, engineering, and construction industry. A transformation empowered by Autodesk, who is helping the designers and builders of today to shape the built environment of tomorrow. Growing demands, evolving expectations, and limited resources. These new realities are creating unprecedented possibilities for architecture, engineering, and construction companies. Technology is helping them to work more efficiently and more responsibly to build cities and the future in a smarter way. And it all starts with BIM. BIM is the holistic process of creating and managing information for a built asset. Based on an intelligent model and enabled by a cloud platform, BIM integrates structured, multidisciplinary data from planning and design to building and operations. From architects, engineers, and contractors to owners and operators, everyone can collaborate remotely to create and manage projects in a better way. BIM also generates insights that empower decision-making and accelerate better project outcomes. Design teams can use computation to quickly generate and analyze multiple options, focused on results. Manufacturing processes help teams to design, optimize, and prefabricate components in factories that are then transported and installed on site using accelerated assembly methods. With design, construction, and operational data, BIM produces a dynamic, up-to-date digital representation of a physical asset. This digital twin enables informed decisions across the entire project lifecycle and sets the stage for future projects. This is BIM. It's the foundation of a digital transformation in the architecture, engineering, and construction industry. A transformation empowered by Autodesk, who is helping the designers and builders of today to shape the built environment of tomorrow. Growing demands, evolving expectations, and limited resources. These new realities are creating unprecedented possibilities for architecture, engineering, and construction companies. Technology is helping them to work more efficiently and more responsibly to build cities and the future in a smarter way. And it all starts with BIM. BIM is the holistic process of creating and managing information for a built asset. Based on an intelligent model and enabled by a cloud platform, BIM integrates structured, multidisciplinary data from planning and design to building and operations. From architects, engineers, and contractors to owners and operators, everyone can collaborate remotely to create and manage projects in a better way. BIM also generates insights that empower decision-making and accelerate better project outcomes. Design teams can use computation to quickly generate and analyze multiple options, focused on results. Manufacturing processes help teams to design, optimize, and prefabricate components in factories that are then transported and installed on site using accelerated assembly methods. With design, construction, and operational data, BIM produces a dynamic, up-to-date digital representation of a physical asset. This digital twin enables informed decisions across the entire project lifecycle and sets the stage for future projects. This is BIM. It's the foundation of a digital transformation in the architecture, engineering, and construction industry. A transformation empowered by Autodesk, who is helping the designers and builders of today to shape the built environment of tomorrow.
Good afternoon, everyone. Let's wait for others to join, and we will be starting in 2-3 more minutes. Right?
Growing demands, evolving expectations, and limited resources. These new realities are creating unprecedented possibilities for architecture, engineering, and construction companies. Technology is helping them to work more efficiently and more responsibly, to build cities and the future in a smarter way. And it all starts with BIM. BIM is the holistic process of creating and managing information for a built asset. Based on an intelligent model and enabled by a cloud platform, BIM integrates structured, multidisciplinary data from planning and design to building. From architects, engineers, and contractors to owners and operators, everyone can collaborate remotely to create and manage projects in a better way. BIM also generates insights that empower decision-making and accelerate better project outcomes. Design teams can use computation to quickly generate and analyze multiple options, focused on results. Manufacturing processes help teams to design, optimize, and prefabricate components in factories that are then transported and installed on site using accelerated assembly methods. With design, construction, and operational data, BIM produces a dynamic, up-to-date digital representation of a physical asset. This digital twin enables informed decisions across the entire project lifecycle and sets the stage for future projects. This is BIM. It's the foundation of a digital transformation in the architecture, engineering, and construction industry. A transformation empowered by Autodesk, who is helping the designers and builders of today to shape the built environment of tomorrow.
Welcome you all to our today's workshop. So let me share my screen. Right. So welcome you all to today's workshop, that is exploring the potential of Dynamo for energy optimization. So first of all, my name is Prakriti Goyal and I'm working in Capricorn as BIM Specialist Architecture. So I'll be taking today's workshop. Now, first of all, the agenda for today. So I'll be introducing the company, and then we'll discuss about the basic introducing the energy optimization and through Dynamo, and we'll have a demo session for that. And if you have any questions, Q&A session will be there, so you are free to ask any questions regarding the workshop. And then the last is the vote of thanks. So first of all, I'll introduce our company. So Capricorn Technology. So our main motto is to help our customers unleash the ideas to create a better world. Like we are since 1987, approx like 20,000 plus Indian customers. And as a global alliance, so we, Arkan's company, is actually a global alliance company. So is building a network of world leading partners with platform to deliver a portfolio of solutions that help our customers design, build services. So we are actually a whole group, and we like in entire world. So we have three parts. One is Americas, EMEA, and APAC. So for APAC, like for India, we are the ones. Now, let's first start with the energy optimization. Now, why we go for the energy optimization nowadays, right? So, first of all, like again, welcome you all to the this workshop that is exploring the potential of Dynamo for energy optimization. Over here, you will discover like how we can actually use Dynamo for developing automations, right? So like if you are developing the BIM model, if you are working in the BIM platform, BIM workflow, so Revit actually helps in that. Now, when you are developing the BIM model, how you can provide automations, how you can generate the energy optimizations, energy analysis, solar analysis through Dynamo, right? So let's get into the first part. So first we'll discuss about like why energy optimization. So again, due to like we are actually now are conserving energy to develop the sustainable development approach, right? We are actually going towards the net zero approach, right? So why? Because like a building with a net zero energy consumption means the total amount of energy used by the building on an annual basis is equal to the amount of renewable energy created on the site. So like we are actually using renewable energy like solar energy. So for that, energy analysis is actually important, right? If you are going for the glazing, like exterior glazing, so how this actually impacts all of like full energy consumption of your building, right? So are you like going for the like, is there any heat gain, right? Is there any cooling loads, right? So that analysis is actually important for like for checking like if the building is actually using all the renewable energy or there's any consumption, energy consumption, right? So we have to cut it down over here to create a net zero approach, right? So if I talk about the different strategies we have, so this uh, everyone knows like what are different design strategies we have for like cutting down those energy consumptions. So first we have passive design strategies where we have like providing different sunshades and like insulations and like shading devices for insulating, like for uh, providing daylight. So direct heat gain we don't use, like we don't need inside the building. So for that we need diffuse daylight, right? So for that we provide sun shadings, right? And the building orientation, so to check the building orientation, the sun path analysis, sun path direction is also necessary, right? And if I talk about active and like active design strategies, so you are actually going for like uh, solar panels and all, right? So again, like over here, heating and cooling systems are required. So heating and cooling load calculation is necessary for this, right? So now if I talk about in Revit, so because Revit, like in Revit, you are developing a BIM model. Now in Revit, you are developing the BIM model from scratch, like from concept stage, right? From the like if I talk about in project life cycle, so from conceptual stage you are developing the project. Now you can provide the energy analysis in throughout the life cycle. So by first you can create the conceptual stage. Over there you can actually provide the conceptual design at early stage, as well as when you are developing the design, like when you are working like creating the working drawings and providing materials to the building, to the BIM model. So at that time also you can provide energy analysis. But the like over here by default Revit, like we cannot go for like solar analysis in detail by default. So we have to like install the plugins. So solar analysis for Revit and energy analysis for Revit. So we have to install the plugins and then we can work on it. But through automations, through Dynamo, we can use the BIM, like we can go for analysis inside Revit. We don't have to go for like for certain cases, we don't have to go for plugins. We can actually use automations in terms of energy analysis or maybe solar analysis. So let's see how this works. So now let's come to the first computational BIM. So over here, because everything we are doing is automation, like automations. So why automations? So first of all, if I talk about computational BIM, now before computational BIM, what is parametric design? So parametric design, if I say the like if you are developing a BIM model, in that BIM model, you are providing parameters, right? Let's say if I talk about doors, you are providing length, width, your height, right? And your material. So you are changing those doors, you are changing those sizes, parameter like materials at the at each and every stage of your project. So parametric means whatever information you are providing, it will be changed. Like you can change these parameters according to the phases, according to the project life cycle. Now, computational design is actually a next level of the parametric design where computer actually involves. So if I talk about in basic, like in generic terminology, so right, in generic terminology, you as the designer, you as the architect, designer, engineers, you have the design related decisions. So you are the human intelligence, and which involves with the computer algorithms, computer language, it will be created as the computational design. Now, if I talk about the exact meaning of computational design, so it is the application of computational strategies to the design process. Now, what is the computational strategy over here is refers to the process of taking design related decisions using computer programming language. Now, why do we need this? So again, if you are going for the calculative, like complex calculative in BIM, right? So this involves using algorithm, logics, parameters, and calculations to BIM model in order to optimize the design process. Right? So now, if I talk about the real context, in real context, how computational design is actually used. So let's take an example of the dynamic facades. So over here we have 5 built dynamic facades, in which one is the example is Kaifer Technique showroom. Like over here you can see these are actually acting as a shading devices which controlling like the motors behind this controlling the like actually controlling the sun power direction. Same is in the Brisbane airport. Over here, the facade is actually moving according to the wind direction. And Al Bahar Tower, where we have the PTFE panels, again, it is actually working as the shading devices. And again, like the motors, like electric motors are actually calculating the sun power direction, right? Now, then like over here, you can see like not only facades, we can actually use computational design in any project, any calculations. So now if I talk about like this is the large building. So again, like dynamic facades are just one example. If you are developing the complex structures, if you are developing the organic structures, if you are developing some computations, quantity takeoffs, detailed quantity takeoffs, and some complexity in BIM. So you are going for the computational design where computer language is involved. Right? Now, if I talk about the like every programming language we have, let's say C++, your HTTP, like HTML. So all the websites that you develop are actually like all the websites that are developed over there and like in the net. So those actually have certain programming. So there are two type of programming. One is text-based programming and visual-based programming. So visual programming is actually main necessary for computational design. Now, if I talk about text-based programming, so text-based programming is just like in each and every sentence, there are certain syntaxes which you need to write. And those statements, like those sentences means a different functions, right? So just like we have in C++ or the HTML. But if I talk about computational design, visual programming is actually preferable. So if you see over here, this is the example. So over here, you can see like these rectangular boxes are called nodes. These nodes help you to perform a certain task, right? So uh, right, so over here you can see over here it's like Excel file path. So you are choosing the Excel file path. It means like that. So visually you can actually perceive like what node it is used for, what purpose, right? So you can see over here data dot import Excel. That means all the information from the Excel you are exporting, like you are importing it to Revit, right? So this is your visual programming. Now, if I talk about a visual programming tool that enables you to, let's say, perform certain tasks, let's say for design related decisions, right? For let's say providing computations in BIM. So that is so first of all, let's take an example of organic. Like everybody has discussed, like everybody has created these origami models, or maybe like in architecture college we actually develop the like develop the develop the models, right? So we had to we had provided with the text based instructions and visual like graphic instructions. Now over here you can see, to develop this paper crane model, we actually give we need like these two are given, like text based instructions and graphical instructions. So what I prefer, because I'm an architect, so what I prefer is the graphical instruction, because again, like I can actually perceive, like by actually viewing I can develop it better, right? So again, like for computational design, for providing design related decisions, we actually need to act visually, right? We need to perceive visually. So that is why visual programming is preferable for computational design. Now, if I talk about visual programming tool which helps in design related decisions, computing BIM model, so Dynamo is the tool in which we provide complex geometries, in which we create complex geometries, compute in BIM model. So Dynamo is the one. Now, what Dynamo is exactly? So I'll read this over here. So Dynamo is a tool that provides graphical access to the programming interface. So if you don't have any programming interface, like programming experience, like C++ or maybe Grasshopper, if you don't have any experience with the programming over here, you can still easily access Dynamo. So it is actually very much easy for non-programmers as well as programmers. It provides a visual approach to programming more suited for architects, designers, engineers. And currently, the following, like these are the tools. These Dynamo is not a part of Autodesk. It is actually separate. So like the website of the Dynamo is dynamobim.org, right? So it is actually separate, but it is used in Autodesk softwares as a plugin, as an inbuilt plugin. So we have different tools over here. So one is Dynamo Sandbox. Like it is actually open source environment with free limited amount of functions. We have Dynamo Revit. So in 20 like in 2019 or till 2019 you had to download it uh, from the website. But now, from 2020 onwards, the Revit has been, like the Dynamo has been an inbuilt plugin in your Revit. So if I talk about Dynamo for Civil 3D for infrastructure projects, Dynamo for format for conceptual design, again for conceptual like or organic, we can say, models projects, and Dynamo Studio, which is actually now uh, disabled. So right now they don't have that anymore, right? So now, because we are developing the BIM model in Revit, so that is why we are going to look how Dynamo is useful for BIM modeling, like for modifying the BIM model in Revit. So first of all, to access, like these are the users. So first of all, how your Dynamo can be used. So generally, like by default, we access the information in the Revit, like access the number of walls, number of doors, like what type of wall, like what type of material we have used for walls. So we actually create schedules to access these certain information. But by default, like schedules cannot be exported to Excel, right? So directly, right? So in newer version, they can be exported. Again, they are not live linked. That means if you change any information in Revit, you have to again and again export it. So Dynamo, what it does, it will create a live link between Excel and Revit, which, like if anything, if any changes are there in Revit, it will be affected in Excel and vice versa. So Dynamo actually is like creating the link between them. Second, automative repetitive task. So if I talk about in terms of like sheets, so in a project, suppose like 100 sheets are to be created to complete one project. So again, one sheet, let's say, takes 2 hours or 3 hours to complete. So through Dynamo, we can automate that task, automate that repetitive task in creating like sheets in one go, as well as like grid to grid dimension, that is also like a repetitive task, so we can automate them. And in terms of energy optimization, again like shadow analysis, so for each and every plan, like for each and every time slots, for each and every, like for each and every month, for each and every, like if you are providing shadow diagrams, right? So that is also repetitive task. You had to like need to like manually change the settings, sun settings, like shadow settings, right? So you can actually automate that task through Dynamo. Now if I talk about generative design actually is an AI. So it means like it will give you suggestions on the design briefs that you provide, like let's say it gives you various options. So if you are developing furniture layout, right? So furniture layout of office, so you just need to provide number of employees, number of furnitures required, and where are the fenestrations. So according to the fenestrations, according to the outside view, according to the like number of people, so generative design will give you thousands of options, and you can choose one of them, and that will be implemented in your design. So that is your generative design. It is actually a part of Dynamo. Now the compliance check. So if your like BIM model is correct or not, to check that we need building bylaws. So Dynamo actually helps in that as well. So you can actually compare them, right? So now today we will be discussing on Dynamo optimization, like Dynamo for energy optimization. So how we can actually go for solar analysis. So like if I talk about the main example that we discussed in the computational design, so the facades. So facade, how facade actually is created, like if I talk about the facade simulation, the facade working of facade during like according to the sunpa direction. So that is the most important thing once like if you are developing the complex geometry, if you're creating the complex BIM model. So the facade is important thing, how your shading devices are actually working. That is the passive design strategy, first important strategy that we need to consider, right? So before going to the demo session, so first of all, Dynamo is actually okay. So Dynamo is actually the programming language, right? Now, if I talk about like computer, if I talk about design related decisions by architect, so we actually go for like length, width, and height, right? But computer language doesn't understand those. So we have to break it down our design related decisions to computer language. So data types actually help on that. So if we are talking about comments, description, so that means a text based instructions. So string is used for text-based instructions, like number of doors, number of columns to be placed. So that is non-decimal numbers, and that is breakdown into integers. Your length, volume, area, and decimal numbers, which can be like converted into double. And the list of elements, like list of walls that you have created in the BIM model, list of doors that you have created in the BIM model. So that is actually list, right? And if I talk about the visibility parameter in Revit, we have yes or no option, right? Do you want to show the partition or not, partition wall or not, right? So over there we have yes or no. But if we convert it to computer language, it is called true and false, that is Boolean. So these data types are actually important in developing the scripts. So now let's take the example of the facade. So I'm taking the Kaifer Technique showroom over here, Kaifer Technique showroom facade. So, right, so just give me a minute. Right. So over here, I'll go for the Revit. So we have already created a facade and panel over here. So I'll just go to that. So Dynamo can be worked in conceptual like different templates as well, like family template, conception mass template, as well as your project template. So over there you can actually see that like right? So So over here you can see this is the like this is the facade that we have developed for the Kaifer technique. Over here, if you see, this is the curtain, like this is the pattern, like this is the panel that we have created, which has the like which is actually adaptive. So like if I go to edit family, you can see that like how this panel is actually working. So if you want to know more about these details, you can just like contact us. So like in the end we will be discussing the Capricorn program. So like over there, like in one of those programs we actually define the like how to create the panels. So over here this is actually the panel, and over here we have closing percentage. So like how much the panel will be closed. So if the panel is, let's say, 40%. So you can see this like this closing percentage actually enables like how much your panel will get opened. So this we need to control it through like what we can say like the sun direction. So first of all you need to check, like you need to select the sun settings. So let's close it. right? So now what I need to do, I need to first check on select check on the sun setting, sun part direction. So because we are in the conception mass, by default we don't have over here the option to turn on the sun path. I need to go to 3D view, and then I need to check on the sun path. After this, what we'll do, we will be creating the script for modifying our BIM model, that is modifying the facade, and we will be simulating the facade according to the sun path. So that is why we need sun path over here, right? So now I'll be opening Dynamo for this. So again, if you any version, in any version, if you start with first time like opening Dynamo for a long time, like again, it might take time. So yeah, let's wait. Okay, so yeah, so before going to demo session, first of all, we'll discuss in three parts. So first, I'll be discussing about the how facade simulation is actually done, and how we can actually generate the shadow diagrams, right? So shadow analysis through floor plans, right? So I'll be opening Dynamo now. Now, so my Dynamo is open now. So first of all, I need to create a new script. So I'm creating a new script over here. And this time, first of all, I need to select the families that we have created. So over here, if you see this panel, so this panel is actually your Kaifer panel. So I need to select it over here. So let's select it. So I'll go for family types. So guys, if you have any questions, if you have any queries, you can just go for the Q&A, right? So first of all, I need to select the families and all the family over here, all the instances of the family type, right? So now I'll be selecting them. And over here, because we are developing the like we are developing the facade simulation. So over here, we need sun direction as well as the facade facing, like at, like in which direction the facade is facing. So both directions we need. Okay, so over here, first of all, I need the adaptive center point, like adaptive location. So because this is your adaptive families, so we need adaptive location, adaptive component location, right? After this, what we need, so over here you can see we have two things, like we have sun, like at where the sun is actually facing, so we need the sun direction as well as the sun direction as well as the panel direction, so that we can actually check like at which angle the sun is facing the facade, and at that time your facade should be closed. So that we need to check, right? So over here we have the points, so I'm just creating, like I need normal points right now. We don't have the center point, so let's create the surface. So I'll be creating the first, right? So you can see backend it is actually working, right? So because like in some cases your like if your script is actually larger, so it is preferable to go for the manual. So when your script is completed, when you are satisfied, you can just then run the script, right? So now what I'll do, I'll just create the script over here. So I need to provide the surface, so I'm creating the surface over here. Right, you can see over here at the background, right? After this we need the normal, like the we can say the when the surface is created, we need center point. So this point is actually needed. So I'll go for, so over here I need just surface and then the center point, right? So after this we need the normal point. So over here you can see that the center point is created, and this will create the direction, like where the side the facade is actually facing, right? So over here we need normal point, right? So this will be the surface and this will be the point. So over here we have now vector in the sense the direction, right? Now to visibly check like how like how direction, like where the facade is actually facing, right? So over there we can actually visibly create the line. So we need line by direction, so that the direction will be a vector. So the start point will be this, and we can provide the length over here. So it will be, let's say, 10 units. right? I'll run the script. So you can see how this is actually like looking. So this will tell you like at where our like facade is actually facing. So again, we have to do the same thing with the sun. So we need sun, like according to the sun settings, we need sun direction, right? So let's do that. So I'll be selecting the sun direction over here. So first of all, we need current sun settings according to the project. And then we need sun direction so that we can get the vector. So over here we have one vector. We need to repeat it according to the list of elements. So, right. And then we will be repeating it. The item will be our vector and the mount will be our list, right? So over here we get the sun direction, sun vector, right? Now over here again we can create the like visibility over here. So this will be our direction. Let's run the script. So you can see over here in the background, we have two directions. One is sun direction as well as one is the how the facade is actually facing. So we need the angle between them, right? So let's go for like if we are comparing two vectors, two directions like facade direction and the sun direction, we need to compare them. So angle like we are going for the vector over here. Right? So angle with vector. I need both the vectors over here. So we need directions over here. Right? So in the end, these are the vectors that we got. Now we need to provide the same information. We need to use it in a closing percentage that we have in the panel family. So the parameter, like we need to provide these information so that like the panel will work according to the sun pi direction. So let's provide that. I'll just provide it so that it will be an obtuse, like acute angle, right? So it will be like this, right? Now I need these acute angles, like I need uh these for the closing percentage, closing of the panels. So let's provide them. So over here, first of all, I need the panel. So over here, this will be our panel. Closing percentage will be the, so exact nomenclature you have to provide over here. So it is actually space sensitive and case sensitive. And this will be a value, right? So let's run the script. So over here, you can see how this actually works. So you can see like now what I'll do, I'll like for you guys, I'll go for automatic so that you can check like when I change the sun direction, how your facade will actually work. So because we have different like large number of components, now you can see over here. So the panels which were closed over here, now they are like which were open, now they are closed, right? So you can see the difference. Yeah, now you can see the distance. Yeah. So this is how you can actually control the facade simulation according to the sunpa direction. Right? So this is how you it works. Now there's another script. So like this is how you actually go for facade simulation with the like according to the sunpa direction. Now if I talk about the like like shadow diagrams. So what are shadow diagrams? Actually, if you're developing the floor plans, so you are providing the shadow, you are actually analyzing the shadow at each and every time. So you are actually providing the time, like over here the date and the time and the year. So everything over there you actually provide. So by default, so let me save the script. So I'll close the Dynamo for the time being. So in this case, I'm just using the sample project and maybe like one flow plan where we have the shadow placement. So I'll go to any plan, let's say site plan. Now, by default, if we provide the shadow analysis over here, you just need to change the sun settings over here, right? Sun settings and the direct, like, and these, like, if I talk about still day, still, so you need to change the date and time manually. Everything has to be done manually. But through Dynamo, we can automate this task. So shadow diagrams are basically the diagrams where which actually shows the shadow placement, like where the shadow is actually falling. So according to that, you can actually provide the shading devices, right? So this is actually important. So now with this, I'm creating the template over here. Let's create a template. Now for the workshop purpose, like I have created that script already, and we are just playing it through Dynamo Player. So I'm creating the first like the view template over here. So I'm just assigning it. Now, after this, I'll just open Dynamo first. And now over here, what we'll do, we will be like first, I'll show you how the script is actually created, and then we'll discuss like how the uh, Dynamo Player like actually works. So Dynamo Player, like what is Dynamo Player over here? So it is just like playlist. So you are creating the like you are creating the playlist of Dynamo scripts. So that playlist can be like if you are working in, let's say, residential project, it can be achieved. It can be like same script can be played in different like different projects like commercial, instruction, like industrial. So you just need to create one script over here. So in a firm, in a BIM firm, one like one person is dedicated to create the scripts, and like others will be playing that script. So let's say if you get the script from the client or consultant, different consultant, so what others will do, they will be playing that script. So playing is actually important over here, right? So over here we have created two scripts over here, like for creating the shadow like diagrams. We have created two scripts. So one is creating views with day and time. So over here we have created, like we will be creating the views according to date and time. So you have to specify the date and time over here. You have to, like over here you can see, you have to set date and time over here. Once date and time is developed, you are creating views like according to the nomenclature, right? So nomenclature, in the view nomenclature, your date, time, everything will be there. And after that, you are creating the flow plans. So because this flow plan I'll be using, so you can go for elevation and section. So this script is only used for flow plans. But again, the same script, you can modify it to create the elevations and sections or maybe 3Ds, right? And then over here, we are applying the view template. So you have to select the view template as well. So this is actually Dynamo Player worthy, where we actually provide is input. So just like in Google Forms, we actually provide inputs over here, and the Dynamo will do the rest thing, right? So what like this is one script, right? And the third, like in the second script is actually, so this is your, like we are actually providing the shadows, like shadow placement according to like shadow intensity. You can actually control the intensity over here. So over here we are actually creating the shadows according to the date and time, according to the nomenclature, like view nomenclature. So whatever, let's say September 10th and 12 a.m, right, 12 p.m. So at that time, what is the shadow? So the details of the shadow it will take from the view name. So view name, view nomenclature is important over here. And the intensity also you can actually change, right? So let's play this script over here. So I'll go for Dynamo player, right? So in this case, what I've done, I've selected the shadow template, and then the same plan we'll copy it into different like into different maybe time zones, like into different, let's say the months, right? So we have to first specify the date, right? The year, the date, time, like, right? I like hour. So these um, informations are important for developing the shadows, right? So let's see how this actually works, right? Yeah. Okay. So over here, so before this, like first of all, you have to check the settings and all, like sun setting device, like sun setting and location is important. Location of the project and the like, that is important. So this is actually in somewhere in the Barcelona, like the location has been set already. Now if I check on this over here, so we have creating views with date and time. So I'll just go for edit inputs. So guys, like again, like if you have any questions, you can just go to quick Q&A chat box and just ask any question. So over here, you have to provide the date and time. So 2024, let's take 2024, uh, right? And let's take maybe September, right? And let's provide the date, maybe 3rd September, right? So why we are providing end and start? So it gives me range. So whatever is the range, number of plans will be created. So start and end range. So we have created a range over here. So it will give you that number of amount of flow plans, right? And then we have to provide hours as well. So like for hours, we'll have different flow plans. So let's start with the maybe, so it is actually 1 to 24. So 24-hour time period. So it will be, let's say, let's go for 9 and 15. And let's provide the prefix over here. So yeah, let's provide the prefix over here, maybe shadow, right? And then the level one. So in this project we have two levels, so level one and level two, and so on, like roof line. So which level plan you have, like you want to duplicate? So we are just duplicating the flow plans, right? And then we need to provide the like template over here, that is shadow diagram. And let's run the script. So you can see over here how many like flow plans will be created if I run the script, right? You can see according to that like according to the numerology, like according to the naming, like according to the date and time, the shadow has been created. And now like the views has been created right now, right? But what we need to do, again we need to set the shadows with respect to the naming of the views, and we need to change their intensity, shadow intensity, right? So the second script will come in handy. So I'll go for shadow and sun settings. I'll just go to edit over here. I'll just need to select the view. So this is the view, right? So I'll just go for prefix. So the prefix should be same. Prefix of the view should be same. And you have to provide the shadow intensity. Let's play this. Like you can see, this is your first view. You can check, like you can see if I go to the different view. So let's say it will change in the active view. Like you can see, I need to just shift the view, and the shadow will be done according to that, according to the placement, according to the view name. Like you can see. So if I do like in maybe 3 o'clock, so what is the shadow placement of the building? Like this, right? You can see. If I talk about at 12 p.m. like this. So you can see this is how you can provide the shadow diagrams, right? So like shadow diagrams are actually like important for like seeing how the like the sun orientation, like to explain like the uh, like different site planning as well, right? And shading devices as well, right? So this is actually important. So this is how you actually like create automations through Dynamo. And Dynamo player actually is helping you to play the script in each and every view, in each and every project, right? So same script you can use it for different projects, right? The next is like the last script for today, like we have discussed. So heat load calculation. So the repetitive task over here, if you are creating the heat load calculation, so the repetitive task is you're creating spaces, right? So if you have created rooms in, let's say, in linked file, or maybe like if you are creating the if you are calculating heat load calculation in the same architectural file, right? So you have to again create spaces. You have created rooms already, but you have to create it, you have to create spaces as well, right? So same Dynamo can help you in that. So I've created for the like I have created the script for the like them workshop only. So room two spaces. So this is the project I'm using. So currently to check that in this project there are no spaces. So what I'll do, I'll create a schedule. I'm just creating a schedule over here. Look, look, you can see over here that the script is not like the spaces are not yet created, right? Through Dynamo, I'll just run this script, and you can see through Dynamo, the spaces are now created, and you can actually see how spaces have been created. So it is actually converting, like it is actually taking the rooms as a reference, and there they are placing the spaces. So over here we have selected the rooms, and their like room name and number and the location, their center point, so which is used for like space placement, and the level, like in which level you want your you want your uh, like spaces to be created. So I've selected all the levels. So currently we have like over here 6 levels, and we have over here 14 room names. So according to that, 14 spaces have been created, and you can see their name are here. So like you can see in schedule, they are created, and now with no time you can just go for analysis. So if I go to analysis tab, I can just go for heat load calculation, and then you can just go for calc. So like you have like in one go, like your spaces have been created, and then you can just go for heat and cooling loads. and like through Dynamo you can export this the report that will be generated, right? So many automations you can do it through Dynamo, which will help you in energy optimization. So there are various things like solar analysis, like solar hour calculation. So everything can be done, but again, we have a short time, so that is why we are not discussing more in detail. So you can actually anytime you can go for the our Capricorn programs. So before going to the Capricorn program, so over here, yeah. So over here we have two major programs. One is your like BIM for design course. So like this is for architects, civil engineers, interior designers. So over here, this is actually for 4 months. So from project life cycle, like we are actually going for like live projects, and over here you will be able to actually know like how to implement. So this is actually BIM implementation program. So after this you will able to know like how you can implement BIM in your project, current projects, new projects, right, completed projects, right? And like this will be helping you to like make your skills higher in your in the BIM platform. And the second is the advanced Dynamo for design. So whatever we have discussed in today's workshop, so everything will be there in the advanced Dynamo for design. So like you can actually check this. So before this, like before going for this course, you have to have a certain knowledge of Revit portion, like Revit families and parameters are actually important. If you know this, then well and good that like you are eligible for this course. So first of all, again, like for advanced Dynamo, you have to know the basic of Revit. Like the basics of Revit is important, right? So now we can have a Q&A session. So let me show you like this kind of report you will get in the like heat load calculations. So you can see over here, you can further on export this to PDF and like Excel to share it with the different consultants, right? So if you have any questions, we can discuss right now. So Q&A session is now open. So if you have any questions, then yes. Okay, I think there's no other questions. So what we can do, let's end the session over here. Okay. So bye everyone. Thank you. Thank you everyone for joining the today's workshop.